Okay, here's our second video for section 2.2. So this is our last video actually. We'll finish up this section. We're going to talk in this video about the number of subsets a certain set can have. And so if I have an empty set, how many elements are there? Well, there are none, but how many subsets can I write if I have an empty set? Well, it would just be that empty set. So it would just be one subset. What if I have the set A? How many elements are in that set? Well, there's one element. Well, how many subsets could you write if you have a set that contains the element A? Couldn't you say A is a subset of A because every element there is in the original? But couldn't you also say that the empty set is a subset of A? Remember the juice analogy? If you pour an empty set into set A, it doesn't really add or change it at all. So an empty set would also be a subset of A. So that's actually two subsets. So if I have one element, I end up getting two subsets. If I have 0 elements, I end up getting one subset. It looks like it increases by 1, but let's see if that pattern holds. What if I have 2 elements in my set, like this one, A and B? How many different subsets could we write? Well, couldn't I write AB? Couldn't I write A? Couldn't I write just B? Because all of those are subsets of AB. But also, I can write the empty set again, remember? And so if there are 2 elements, I end up getting 4 subsets. So it's not just increased by 1 this time. It almost looks like it's doubled. But let's see again if that pattern holds. What if I have 3 elements in my set, A, B, and C? I could do A, B, and C. I could do AB. I could do AC. I could do BC. I could do just A, just B, just C. And remember the empty set. How many subsets is that? That's 8, right? Oh man, it's not really doubled. And what happens if I have 4 elements or 5 elements or 6 elements? Now, I wouldn't be so mean to make you write out all of those. So let's see if we can come up with a pattern that would work to figure out how many subsets there would be, no matter how many elements I have. Do you notice any sort of pattern of how I can go from 0 to 1, 1 to 2, 2 to 4, 3 to 8, and any number of elements to the number of subsets it has? Well, if you cheated, if you look down here, we actually have 2 to the nth power, where n is the number of elements in our set. So if I have 3 elements in my set, I could say 2 to the 3rd power, 2 times 2 times 2, which is 8, would be the number of subsets I would have. So then how many proper subsets would I have? Remember, proper subsets are subsets that aren't exactly the same as the original. Wouldn't that just be 1 less than 8? Because one of them is exactly the same in each of these examples. And so we could, no matter how many elements we had, figure out what number of subsets that set would have by using these two formulas. If there were 16 elements, we wouldn't want to write all those out, but we could figure out that it had 2 to the 16th power of subsets, and then it would have 1 less proper subset. Let's do example 4. Example number 4 says, find the number of subsets and the number of proper subsets for each of these sets given. In the first one, I have the set that contains A, B, C, D, and E. Well, how many elements is that? That's 5, right? And so I can figure out how many subsets we could possibly make with those 5 different elements by taking 2, raising it to the 5th power. That's 2 times 2 times 2 times 2 times 2. You should end up getting 32. I wouldn't want you to write out all 32, but you could tell me, if you needed to, that there should be 32 subsets you could make with those 5 different elements. So then how many proper subsets could you make where they're not exactly the same as the original? Well, if one is exactly the same, all the other ones aren't the same, and so those are proper subsets. So that would be 31, 1 less than 32. Do the same idea with example number 4b. First, figure out how many elements you have in the set given, and then figure out how many subsets and proper subsets. Pause the video and see if you get the same numbers I do. Okay, so for part B, I have the set of all x's such that x is, do you remember these notations? X is an element of the natural numbers, remember 1, 2, 3, and on, where x is greater than or equal to 9, but less than or equal to 15. That's 9, 10, 11, 12, 13, 14, 15. I got 7 elements, did you? And since there are 7 elements, how many subsets would there be? Well, I could use the formula 2 to the 7th power. 2 to the 7th power, if you have your calculator, ends up being 128. There are 128 different subsets you could possibly make with those 7 numbers. Well, how many proper subsets? Well, it's just one less than that, so 127. Make sure that you know how to use that formula so you can figure out how many different subsets and how many different proper subsets. Okay? All right, the last thing I would like you to do is I'd like you to do these practice problems. These are kind of try-it problems, somewhere off to the side, a separate sheet of paper, something like that. This is kind of practicing the different notations. And remember how just a little bit of a different notation makes a big difference in your problem. So I'd like you to write down these 4, and I would like you to determine if you think each of these statements is true or false based on its notation. Pause the video, answer the 4, and then let's see if you got them right. So number 1 says 4 is an element of this set. Well, is 4 an element in this set? That's true. 4 is inside that set. So let's jump over here to number 3 because it looks really similar to number 1, but there's a little bit of a difference there. On number 3, it says set 4 is an element in this set. Now, is set 4 an element in that set? Remember, that was the kind of tricky one. That is a false statement. Because we don't have those extra brackets inside, that statement is not true. Or because we have these extra brackets out here that aren't inside, that's what makes it false. Because the whole set has to be inside that set in order for that to be true. Let's look at the next 2, because those also look similar to each other. This notation talks about subsets. Is set 4 a subset of the set 4 and 8? True, because every element in set 4, this first set, is an element in the second set. So that is a true statement. Those are subsets. Now look at the next one, the last problem. Kind of a tricky problem. That statement is false because this can't be a subset of the other set because he's not even a set to begin with. What is he missing? Isn't he missing those special brackets to make him a set? So we can't say that this little floating 4 is a subset because he's not even a set to begin with. So that would be an example of a false statement. So be careful. Remember, one little notation makes a big difference in how the statement is true or false. Make sure that you practice all the different notations. Make sure that you're practicing your subset and your proper subset. And then we'll move on to section 2.3 in the next video.